Hey everybody, let's get more practice doing the node voltage method and the mesh current method, especially in figuring out which one would be the better option. And really, while you're in school, you should practice both methods so you get a feel for which one works in which situation. But let's do some examples just so I can point out what to look for. So let's say we go with the node voltage method. How many essential nodes do we have? Node A, node B, and over here I'll call this node C. And now we look out if there are supernodes. Yes, right here. It's a supernode. Got a voltage source in between two essential nodes. So then I'm not going to pick B or C as my reference. I'll pick somewhere else. So over here, node A. Now we'll write KCL for the supernode. So let's start over here. 2. Now over here. VB over 50. Over here. VC over 150. Now over here. VC over these two in series, 75. Okay, so we got two unknowns, one equation. We can write the relationship between VB and VC. Which one is more? We just look at where the plus sign is over here. So this side is more. How much more? 25 volts. Okay, so there we go. We got two equations, two unknowns. Now let's say we want to try the mesh current method. Okay, so let me just draw some mesh currents. Okay, and I kind of drew it like that because I was looking at right here. That means mesh current IA is 2 amps. So we already solved that mesh current. That was easy. So now we only have two more unknowns. So we write KVL for mesh B. Let me start right here and I'll go counterclockwise. It's going this way. 150 IB minus IC. Now we're over here. Minus 25. Now we're over here. 50 IB minus IA. Okay, now let's go KVL for mesh C. I'll start right here going counterclockwise. So we got these two in series, so 75 IC, and then now we're over here. 150 times IC minus IB. And here we go, two equations, two unknowns. So I don't know if there is any real advantage of one method over the other. Maybe this looks a little bit simpler to solve the math. Okay, let's try another problem. Okay, let's start with, let's say we do the node voltage method. How many essential nodes? Here, 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 here. 4 of them. So let's say I pick this as my reference, and I'll label the others. Let's say I call this A, B, C. So I have 3 unknown node voltages. Kind of. Actually, node voltage A is 50. Right? So that was easy. So now we actually only have 2 unknown node voltages. So let me just write those out quick. So at node B, let's do KCL, VB minus VA, which we know is 50 over 80. Now going this way, VB over 50. Now over here, VB minus VC over 40. Okay, now node C, KCL, let's go up. VC minus VA over 800. Going this way, VC minus VB over 40. And then this is going in, minus 750 milliamps. And then this way. Okay, so again, VA is known. So we only have 2 equations, 2 unknowns. All right, now let's take a look at the mesh current method. How many meshes we got? 1, 2, 3, 4. Okay, so already we have 4 unknowns. I do note that this is a super mesh. Okay, so then you would write 3 mesh equations. So let's see if we do it quick. So for mesh A, let me start right here, going clockwise. Negative 50 plus, I'm over here now, 80 times IA minus IB, I'm over here, plus 50 times IA minus IC equals 0. Okay, mesh B, let me start right here and I'll go clockwise. So 800 IB, I'm over here now, plus 40 times IB minus IC, I'm over here, plus 80 times IB minus IA equals 0. Okay, now the super mesh, I'm going to start right here and I'm going to go clockwise. So here, 50 IC minus IA, I'm over here, 40 IC minus IB, I'm over here, 200 ID, and that's it, equals 0. Okay, and then there's a relationship between mesh current IC and mesh current ID. Which one is more? ID. ID is more than IC by 750 milliamps. Okay, so 4 equations, 4 unknowns. This one, definitely the node voltage method wins for being simpler. That super mesh helped a little bit, but it's just there's so many unknowns. Okay, let's give this one a try. So we have, let's say, 1, 2, 3, 4, 5 essential nodes. So let's say I pick a reference here that was drawn there, which I'll agree to that one. So let's say we have A, B, C, D, 4 unknown node voltages, kind of. We actually know this one is 75, so that's known. So 3 unknown node voltages. Any supernodes? Yes, right here. Between node A and D is a voltage source. Okay, so then I can write KCL for the supernode. Let me do that one more time. Okay, this. So for the supernode here, VA over 2.5K, and then over here, VA minus VB over 1K, and where are we? Over here. 75, because we know the voltage right here is 75, minus C over 500, and then right here, 75. Okay. And then we go, and then just keep going, right? Node B, VB minus VA over 1K, and then right here, the current is over here, that 12 times 10 to the minus 3, and then over here, VB minus VC over 500. Okay, and then you just keep going, right? VC minus VB over 500, and over here, plus VC over 4250 ohms, and then over here, VC minus, this is 75. Okay, And what else do we need? For the dependent sources, right here, V delta, right here, V delta is VC minus 75. And the current, right here, I phi is right here. So the current is VB minus VC over 500. Okay, so all of this using the node voltage method. All right, now what if we wanted to use the mesh current method? How many meshes do we got? 1, 2, 3, 4. Okay, any super mesh? Yes, right here. This. Okay, so then you would write your 3 mesh equations for the super mesh. Let me just write that. So let me start right here and I'll go clockwise. So 2.5K IA, now over here, 1K IA minus IB. Now over here, 500 IC minus IB. Now we're over here, 4250 IC minus ID. All right, so this is for the super mesh. And then you're right for mesh B. Let me start right here and I'll go clockwise. So voltage is given minus 1250 I phi. Now over here, 500 IB minus ID. Now over here, 500 IB minus IC. Now over here, 1K IB minus IA. And then last one for mesh D. Let me start right here and go clockwise. 4250 ID minus IC. Now over here, 500 ID minus IB. And now over here, 75. And there we go. And then these same two that let me just recycle it from the previous problem. And there we go. So either way, it looks like 1, 2, 3. So node voltage method, we had 5 equations. Mesh current method, 5 equations. So maybe no clear winner here because there is a super node and a super mesh. Okay, so there was a lot of examples. So keep on practicing and let me know if you need help and have more questions. I'll see you on the next video.